Okay, guys, here we go. Last unit of the year, Unit 14, Statistics. This whole lesson today is really just like tons of talking, so it kind of stinks that we're not there together to interact and discuss. So I guess, just do the best you can to listen to me. All right, so day one is called gathering data and variability. The definition of statistics is it's concerned with the collection and analysis of data. It's all about trying to explain variability that occurs in a data set. The example I gave you is why do some plants grow more than others in your garden? Obviously, you see on the news every single day, statistics are everything right now, and they're all over the place. Maybe I wish we had done this unit before. Well, not that I wanted this to happen, but before, because a lot of things that they say on TV, I'm like, we would be discussing those things. All right, so here we go, variability. So variability is outcomes to experiments are different, right? So I'm giving you two different types here. The first one is observational or measurement variability. So we're actually going to do a bunch of different types. So we're going to do natural variability as well. Then we have induced variability. Okay, so we're going to look at different types of variability, like why might something have different outcomes. All right, so this first one here, it says variability that is introduced due to either our measuring instruments not being precise enough or differences in how the two different people might read the measurement. So the example I gave is rolling a Hot Wheel down a ramp and seeing how long it takes to reach the bottom using a stopwatch, right? So, somebody might not hit the stopwatch at the same exact time. So this is observational or measurement variability that might give us different outcomes. Natural variability or individual variability is variability that accounts for the fact that members of the population are simply different. Okay, so look at these. So two people who work out the same amount of time at the gym doing the same exercises lose different amounts of weight. Well, we all know that that's true, right? So that's just natural variability. Two plants that given exactly the same amount of water and sunlight grow different amounts. I know in my garden that happens all the time, and I'm like, what happened to this one? It's just who knows what the chemical makeup was of that one plant. Induced variability. So this type of variability occurs when we have assigned our population or sample to two or more treatment groups, and then we observe the variability between the groups. So induced, I don't know if people have heard of, if somebody's pregnant and maybe they're past their due date, they get induced. That means that they were just given medicine to make the body think that we're ready. So you're just forcing something to happen. So the example I have is two groups are tested on memory. One group is allowed to sleep for 8 hours, and the other group is only allowed to sleep for 4 hours. So we're affecting things. We're inducing this variability. And the other one is two groups are given a drug to help reduce blood pressure, and the other is given a placebo, which is just a fake one, but they think that they're given the real thing. And then this again is induced because we're controlling it. All right, and then the last one I have is sample variability. So this type of variability that occurs when we take multiple samples from a population randomly. These samples will be different due to the randomness of the sampling process. So 500 people surveyed in 2 different states about who their favorite candidate is, and we get different results. Well, that's because some states might be Democratic and some might be, Republican. So that's why the sample matters. Calculating the average weight of a 30-year-old woman at the gym and at the supermarket. Well, the people at the gym probably are going to weigh less. We could also look at right now, if we were to see, with the virus going on, certain states obviously are a humongous amount of people have it, and certain states don't, right? So that's where sample variability can affect differences in data. All right, so the collection and analysis of data are vital steps in decision making. And again, it's crazy that this is all going on, but this is on our TV screens every single day. The whole plan that was just rolled out last night with the phase 1, phase 2, everything, all the decision making is being done on the analysis of the data and, who gets the disease, how fast they get it, can we tell if they have it. So data is collected and analyzed, and then decisions are made, based on what will be best for us. Okay, so we have a population and we have sample population, 2 more words to look at. So population is when information is gathered and includes all of the cases, which obviously, to get all the cases of something, like actually what's going on now, right? We can't get all the cases. But a sample population is more likely what would happen, and that's when every case is not available. So when would we have a population? Well, if I wanted to know the average on my test I gave, once all of you have it, I have the population. So that would be everything. So we can sometimes get the population, but most of the time not. All right, so let's go back to the sample one, because this is the one that happens most often. When all information from every case is not available, a sample population is considered random if the probability of selecting the sample is the same as selecting every other sample. When a sample is not random, a bias is introduced, which may influence the outcome of the study. So, the sample must be representative of a group being studied and be large enough to be effective. So, like, one of the things that bothered me in the beginning was when they were doing, New York was getting so many tests done, so obviously we were going to have a huge rate, and other states weren't getting as many. But anyway, now we know we still have more than everybody anyway. Okay, so here's 2 examples. It says the study of how many people can walk a balance beam. Oh, I'm sorry. The study of how many people can walk a balance beam is conducted in a gymnastics class. That's crazy, right? That would totally be biased because the kids are going to be able to walk on a balance beam. So that would be nuts. The other one I have over here is a study on the hazards of cigarette smoking being done by a tobacco company. That would totally be biased as well because, they don't want to show that smoking is bad for us. Okay, so we always want to look for that bias and make sure that we do have indeed random sampling. All right, random sampling is critical for being able to minimize variability due to sampling bias. If we don't have random sampling, the study isn't worth anything. Everything has to have an equal chance of being selected. Oops. All right, so now we have techniques to collecting data. All of this stuff is just so important, guys, that you understand. Obviously we don't have a Regents going on anymore. I don't know what's going on with August, if there will be one or not, if anyone does want to take it. But what I do know is when you go off to college, pretty much, no matter what your major is, everybody takes statistics. Okay, so it's nice for you to get this little background here. And then some of you might take AP Stat next year. Okay, so techniques for collecting data. So first one we'll look at is a survey. And a survey is something like a written questionnaire, an interview on somebody's experiences, opinions, or preferences. A census, I know we just filled out, well, I gave it to my husband to fill out. It was a survey. A survey is made to reach the entire population, and they always ask things about, how many people you have in your house and the ages, and that's meant to reach everybody. Controlled experiments. Deliberately impose a treatment on an individual in order to observe the response. Okay, so this is super important. Again, I wish I was right there in front of you. A controlled experiment is when we're going to split up into 2 groups. One is the control group. Usually it'll be something with medicine, like we just said before. We want to see the effectiveness of a new drug. So they would give one group the drug and give one group what's called the placebo. Now, what's very important is what I highlighted here. Controlled experiments can suggest patterns or relationships, and they can determine cause and effect relationships, effectiveness of a new drug. So when you're doing an experiment, we can have a cause and effect pattern. But when we do observational studies, now observational is where we just sit back and watch. So I like to always say, like, we're sitting in the bushes outside the classroom, like looking in and just watching what's going on. That's an observational study. It observes individuals and measures variables, but does not try to influence responses. And this is what's important that I highlighted here. When we're doing an observational and you're not doing an experiment, that can only suggest patterns or relationships. Okay, that's about it with that one. It says to determine if a new drug causes cancer, it would be unethical to drug the patients, right? So a researcher observes the occurrence of cancer among those who previously took a drug. And I'll give you a good example of observational as well, because it doesn't have to be in the moment that you're watching what's going on. It can be taking past data. So I know in the 70s there was a drug called flumitamine, and it was for morning sickness. And a lot of women took it, and their babies were being born with deformities. So, like, they were missing limbs. So this was an example of observational studies, because after the fact, they were like, oh my goodness, what happened here? So that's an example of that. And then a simulation. A simulation is where we imitate a process to predict a behavior or a sequence. And we'll talk more about that in some other lessons. All right, so let's just do a couple of questions here. So it says a new medicine is intended for use by adults, is being tested on 5 men whose ages are 22, 24, 25, 27, and 30. And what I want to know is this sample valid? Now, usually I have lots of hands going up, and people will tell me that it's not valid, and then I'll ask why. So who can tell me some reasons why you think this is not valid? Yeah, obviously you can't answer me. Okay, so usually people tell me that it's a small sample, right? I mean, it's only 5 people, and we're trying to test something for, a drug that's intended for adults, so it's a small sample. It's only men, and only 22 to 30, which is not, a wide range there. Okay, so that would not be a nice random sample. Okay. Next. It says a survey completed at a large university asked 2,000 students, so that's a lot, to estimate the average number of hours they spend studying each week. All right, so we want to know how many hours that the kids are studying at this school. Every 10th student entering the library was surveyed. The data showed that the mean number of hours that students spent studying was 15.7 per week. Which characteristics of the survey would create the bias? Okay, so this is obviously biased, right? 2,000 is great. Every 10th student is great. But they're only looking at the kids going in the library? So the kids going in the library are probably the ones that are studying. So choice 4, the method of choosing the students who were surveyed. That would create a bias. That would not be a nice, good random sample. Okay, 7. Cheap Fast gas station is conducting a consumer satisfaction survey. Which method of collecting data would most likely lead to a biased sample? All right, interviewing every 5th customer to come in the station. I mean, that seems pretty good. Interviewing customers chosen at random by a computer at the checkout. That seems pretty good too. Interviewing customers who call an 800 number posted on the customer's receipt. Okay, so I'm thinking this one. Let's just look at the last one. Interviewing every customer who comes into the station on a day of the week chosen at random out of a hat. Okay, so that seems good. So why is it choice 3? Well, we're only looking at the people that called the 800 number. I don't know. I don't know if they were calling the 800. Usually people who call are complaining. So, not everybody's going to call. So that seems like I would be getting a